Okay, so I have the power coming out from this 5-volt port here. It's going to come up to the positive terminal. It's going to come down this wire and up to the potentiometer. Then it's going to come across, and it's going to come down, back over here into the ground. Also, we have this wire coming from pin 13. It's going to come over here up to the LED. And it's going to come across the LED down to this fixed 220 ohm resistor, and that's going to go to ground. And then finally we have the wire coming from pin A0, and it's going to come up all the way over here to this middle port for the potentiometer. Essentially what this is doing is the potentiometer is going to set how fast the light is going to be blinking. This is all set with the code that is provided. The power from the LED is coming from the pin 13, so that's why the power is still going across, even though the potentiometer, if you move it all the way to the left, there is still power. It's just blinking very, very slowly. Okay, so I made 3 changes to the code. The first change I did was I added serial.begin 9600. What this is doing is it is enabling the serial monitor to display data at 9600 baud, or 9600 bits per second. The second change I did was I switched analog read sensor pin to analog read AO. This change made no difference whatsoever because sensor pin as an integer is already set to a variable of 0. So anytime you put sensor pin anywhere on here, it's automatically going to be read as pin 0. The third change that I did was I added serial.println sensor value. What this is doing is it's displaying the resolution on the serial monitor. So what I have over here is a whole bunch of numbers that are going across the screen. If I make the light blink slower, the value gets higher, the resolution gets higher. And if I make the LED if I make the LED light faster, it's going to lower the value. It's going to lower the resolution. Okay, so I have the bumper switch set up here. I have power coming from pin 13. That is going to the control switch for the bumper. Then it goes from the black wire. It's coming all the way over here back to the ground. Pin 7, I have power coming from pin 7. That comes over here to the 220 ohm fixed resistor. Then it goes to the LED and over here back down to the blue wire to the ground. Basically I have this set up. I'll show the code in a second. If you press the button, the light turns on. Let go of the button, the light turns off. So here is the code. I have pin 13 as the initial, the input pull-up, and pin 17 is the output for the LED. I had to do some research for if and else statements. So if the sensor value is high, then the output for pin 7, the LED, will be low or off. And if it is not, then it will be high. So this is the serial monitor. The button is pushed, you get a 0, it's low, and if the button is released, then it'll be 1 or high. Okay, so here's how I have the potentiometer set up for the Vex Robotics. The pin on the left is the black one. This one connects to ground with the black wire here. The pin in the middle is the red one. This one connects to power with the red wire that goes around over here. It's the 5-volt power supply there. The right one is the white one. This one comes up here and follows the yellow wire. This one's connected to analog pin 0. This is the control. So over here for the code, we have serial.begin 9600. This is 9600 bauds for the serial monitor. We have pin mode set to 0 for the input. This is the control input for the potentiometer. And here we have the analog read is set to 0, and we have serial.println for the sensor value. This is going to display the value which is coming from the potentiometer. So over here, if we turn it to the left, the resistance is lowering and the amps is rising. This is the value for the amount of voltage that's going through. If you turn it to the right, the value is going to decrease, which is basically showing that the resistance is building. Okay, so I had the line tracker set up the exact same way. Left goes to, the black goes to ground, the middle red goes to power, and the right white goes to pin A0. This is essentially using lights to determine the data. So the code has not changed; it's the exact same. As you can see, with all the light that's coming through, it's staying at a max of 1021. But as I slowly start to cover it up, the number is going to decrease all the way up to about 370.